Think about solid rock. It's heavy, it's dense, and when it hits the ground, it lands with a dead, silent thud. It absorbs energy. It certainly doesn't sing. But inside the sprawling complexes of ancient India, that basic rule of physics seems to break down. Walk up to the massive structural pillars holding up these temple halls and gently tap the sides of the stone with your hand. Instead of a dull thud, the rock rings out. Distinct, clear musical notes echo across the corridor. You are listening to raw, quarried granite behaving exactly like a precisely forged metal bell. It forces us to ask how builders, working hundreds of years ago, engineered raw earth to carry a tune. To generate a musical note, an object has to do one specific thing. It has to sustain a physical vibration. Standard rock is terrible at this. The vibration dies before a sound can form. The stones chosen for these specific columns are different. Look at the dark, polished surface. This material is incredibly dense and nearly glass-like. It possesses what geologists call internal structural homogeneity. The molecular structure of the rock is perfectly uniform from top to bottom. Because there are no microscopic cracks or sudden changes in density to scatter the energy, a sound wave can travel straight through the solid matter without losing its momentum. The architects who built this weren't relying on luck. They were acting as material scientists, hunting down specific geological deposits with exact molecular profiles. Finding the right stone was only the first step. Notice how the pillars aren't solid blocks. They are meticulously carved into clusters of slender, freestanding shafts, all attached to a single continuous base. In acoustics, an object's physical mass and its exact geometric shape dictate the precise frequency at which it will vibrate. This shows how carving material away acts like tuning a physical instrument. A thick, heavy column oscillates slowly, producing a low, deep pitch. As mass is stripped away to make the column thinner, the vibration's frequency increases, driving the pitch higher and higher. Look closely at a single pillar cluster, and you'll see that no two shafts are exactly the same thickness. Each one was chipped down to a distinct dimension, allowing one single block of granite to produce an entire scale of notes. These structures are doing the heavy lifting of supporting a temple roof, but they are masking highly engineered acoustic instruments in plain sight. If you wanted to calculate and carve a structure to hit these exact frequencies today, you would rely on digital acoustic software and calibrated machinery. Yet, these craftsmen were mapping out complex resonant frequencies using nothing but chisels, hammers, and the human ear. It requires absolute, obsessive precision. One overly aggressive strike could alter the mass just enough to throw the entire note out of tune permanently. If you're fascinated by the forgotten science of the past, you're watching Untold Indian Stories. Make sure to like, share, and subscribe. We know how they built them, but the true intent remains elusive. Were these musical pillars simply a brilliant acoustic experiment? Or did they serve a specific function we haven't figured out yet? And as we study the math carved into these walls, we have to wonder what other scientific capabilities are still sitting quietly in ancient stone, waiting to be decoded.